Welcome back everybody to this new part of my EV conversion video series on this 1978 Volkswagen Bus. I think you're really going to like this one. In this video I'm going to show you how I built this battery box. This is going to house the 6 A123 system battery modules that will build our 30 kilowatt pack for this car, as well as that high voltage junction box. At the end of this video we're going to do our first official spin test of the motor, so stay tuned. Now before I get started on this video, I wanted to give a little bit of a disclaimer, which I don't normally do. And you might be saying, why do you need a disclaimer? About all your videos are around using dangerous things like welders and torches and heavy equipment. And this video will be no exception. I'll be using a lot of this welder to do stuff, but in particular, I'm going to be doing something where I'm hooking up high voltage batteries that are capable of high current outputs. And so I want to make sure that you guys know that that's no joke. You can really hurt yourself or kill yourself when messing around with high voltage and high current capacity type batteries and equipment. So I just wanted to give you that disclaimer that please do not try this at home unless you've done more research than just watching a chucklehead like me do this to his own car. And with that said, let's get going. Okay, so for the materials that I'm laying out here, what I've gotten here is some 1 1/4 inch by 1 1/4 inch hot rolled angle iron, just standard like 1/8 inch thick angle iron. And that was pre-cut to 5-foot sections. And then I got some 1 1/4 inch wide, 1/8 inch thick, just cold rolled steel flat bar. And I'll use this just to, just weld bracing across the different parts. I got a piece of copper bar, another, again, 1/8 inch thick by 1 1/2 inches wide copper bar. And what I'm going to be doing here is cutting off little sections of the bar and bending them into L and U-shaped brackets. And for example, on the end of the pack, where this, when I do the series junctions between this negative and a positive or whatever, I'll angle that 1 1/2 inch fits across here, and I'll basically create an L, well, basically a U shape. So it goes down, across, and then back up. And then I'll bolt each side in to those packs, and that'll be the bus bar for the series connection between the two packs. And then for the parallel connections coming off the end, that'll just be like an L-shaped, little bus bar with a hole in it, and then that will bolt on to the fuse and contactor. And I'll explain that stuff later. All right, a little progress shot here. I started welding in my rods here for the battery holders. You can see I've got one battery in, and that's kind of what it's going to look like. All these 3/8 rods are gonna post up through here. I'll cut them down at some point, and we'll use those to secure them. I originally got this threaded rod from Zora. I probably paid $30 for these things, and ended up kind of probably wasting my money. I didn't realize it was left-hand thread. But what I ended up doing instead is Menards sells these things here. 3/8 inch, 12 inches long, zinc plated carriage bolts. So what I did was, and they're $2.50 a bag, which means like for $20 I can get all 24 of these things. So what I did here is I basically drilled a hole from the bottom. I basically set it up on my sawhorses over there upside down, drilled all my holes out, and then popped the carriage bolt in. The nice thing about the carriage bolt is that you can use the head to kind of level it down once you drill it out. And then I tacked it in on the bottom so it stays put. Then what I'll do is drop the pack onto it. That way the studs will line up because they're not exactly straight, so I'll just kind of bend them in a little bit, line it up, drop it down, make sure it works first, and then I'll finish just welding around the top side. If you're following along on my videos, these are zinc plated. And what you want to do when you're dealing with welding zinc plated stuff is try to grind off some of the zinc plating before you weld. But then as I'm welding, I would hold my breath, weld it up as much as I could, then run out the door, breathe, and let this, I've got the fans going in here, let this air out, and then come back in. So it takes a little bit longer, but just be careful that you don't breathe in that zinc fumes when you weld on it. I've also been working on connector plates. Now this is that 1/8 inch thick, heavy duty, 1.5 inch wide copper plate. So you could see what I did was I bent it into a U shape. On these terminals here, notice that what's weird about this is that there's kind of an empty plate here with some threaded inserts, and then the actual plate that has embossed in it either a positive or minus sign in it. What I noticed was I thought these were kind of like connected together, but what I noticed was when I put my meter on is these are just dead. There's nothing happening with them. So I'm not really sure what the purpose of them is. Maybe they were just another tie down for the batteries for some sort of mounting, but only this plate and the one right here, which would be the negative side of the battery correspondingly, are actually electrically active. The other one is just, I don't know, it's just threaded inserts. What's frustrating about it is on the positive side, the actual 10-pin harness that needs to plug in for the BMS on this side is under the positive terminal, which is frustrating to me. Because what I was gonna do is do these to where I could do it like this, where they go on underneath, then I have room from above to screw them in. But instead I have to go like this. I have to bridge them up above. Still doable, it's just a little bit harder to do because I got to get my hands in under here. And you can see how close the modules are gonna be, right? So I've got room to get my hand in there, but not much room. All right, a little progress shot here, and we have, I think, everything pretty much fabricated and welded, at least for the bottom and sides of the battery box here. If you're not sure how I'm going to enclose this, well, I think it'll become clearer as we go, so I'll just kind of show you that. But as you can see, I'm a little bit, about 1 inch off center here, so everything is going to be a little bit off center, and that reason for that, again, is because I added an extra inch on the positive end, so each pack end will have a corresponding rail here. That's the difference between that side, is I have those uprights in there. Now in the cargo floor itself, I've prepped it. I'm about ready to bolt down the bottom part of the battery cage. I've got the holes drilled through all 4 of the corners and then one in the center. Those will be stainless steel 3/8 bolts all the way through the car. I've cut down everything. Those little spots of white, bright white paint is more of the same color white paint that I painted that battery box with, just to cover up the bare steel where I made some of these cuts and drills. It'll be covered up so you won't see that. I cleaned everything out, made sure I had grommets where they should be, and so now I'm going to go ahead and mount that battery cage to the floor. All right, how about a little progress shot here? Have my wife helping me line up those pegs as I drop these heavy things onto them. Boy, that was fun. I didn't film any of that because there's no room to film, and you just would have saw a husband and wife yelling at each other. So you might notice, why did I leave 2 out, and why did I put this one in when that's the easiest one? Well, I want to go ahead and get at least these packs in so I can measure and cut all these struts here, which are going to tie in all these things and and sit in like that. But then also each one of these, I think I mentioned before, each one of these parallel packs, right, there being 3, right, each one of these is a string, is going to have a contactor and fuse on each of the parallel packs, and that way the packs, when not in use, meaning not charging or not discharging, the packs will be opened up. I mentioned that's why we have these 3 rails on the positive side and extra space here. I put this front pack in because I can get the measurement that I need here by putting it up against there, and I can measure and drill those holes out. I can leave this pack in and drill. This is the only one I can drill from the outside. Then the rest I've got to drill from the inside. That's why I'm waiting on those other two modules. So I'm going to get to that and I'll bring you in when I get some more progress. A little progress shot here. As you can see, I have all of the packs installed. I have cut down all of my posts, and I have finished, or at least completed and bolted and mocked up all of the contactor, fuse, and bus bars on the end positive side here. So we got all three of those done. And what I'm going to do is take the plastic plate and just kind of screw that back down. And I've got a few of these 1/2-inch tall rubber neoprene washers with a 3/8 hole that fit right on here. And then I've got 4 of these struts painted up and cut, ready to go. And so the idea here is that we would put a strut, they all should fit right there, and then a washer and nut, and lock that all down. One thing you might notice is, well, yeah, that neoprene washer gives a good, nice 1/2-inch gap in between this high voltage bus bar and, you know, obviously the railing there. But one thing I'm also going to do, just for extra safety, is I got a little bit of this Plasti-Dip, and this is actually orange, so it's the right color. It's mainly made for tool handles, but it does say that it has insulative properties here. It doesn't say how many volts or anything, so I'm not going to assume that it's the highest grade insulator electrically, but I'm going to go ahead and dip the top of these in that Plasti-Dip, as well as I mentioned before, I started on these bridges, these U-shaped bridges that are going to go in between the series connections. I still got to make 2 more of them, but I'll dip this middle part as well in the Plasti-Dip to insulate it and prevent any issues. For connector cables, I've got a bunch of these old ones from my previous build, these little short runs of 2/0 cable. They already have lugs on them. So again, that bottom contactor stud right there, each of the bottom contactor studs is open. So I'm basing on a bridge, you know, bolt that onto the contactor stud, bolt that onto the middle one, then we'll bolt the next one onto there, and you get the idea, and then the bridge the next one, and then the final one will be basically the positive cable. And same thing over there, bridge those two, and then that bolt on that last one will be a longer one, and that'll ultimately be my negative cable. So I will get all that stuff done, and we'll bring you back in and show you the progress after that. Okay, so a pretty far skip ahead progress shot here. I got a lot done off camera, and I just want to take you through it. The only reason I didn't kind of go into detail of filming every piece of this is just because I don't really think there's going to be a lot of people that are going to emulate this exactly. I mean, it's kind of a very custom thing. So I'll take you through it so you can get some ideas for your own EV project if it applies. Well, here we have our 3 contactors here. We have our copper bus bars all done. Now, I was going to put, notice that I have this yellow on there. I was going to put that orange Plasti-Dip on it. It turned out to be a mess. So instead of the Plasti-Dip, I just used this, like basically this insulative battery shrink wrap, and just to give it a little bit of insulation there. Like I think I mentioned before, I've got these rails on. I went ahead and did full rails on front and back, and they're all bolted in from the top. And then the struts I painted up. Of course, I got the hole patterns there. I'll put all the nuts on later. I'm probably going to take them off one more time when I do the BMS cabling. But you can see there's my bus bar, and it goes into the top of the fuse, then out of the fuse into the contactor, out of the contactor into a 2/0 cable, and did some cables going, you know, linking 3 to 2, 2 to 1, and then 1 going out, the positive cable going into this new junction box that I affixed to the back of the wall there. And here you can see the middle bars. Now on the negative side here, what I did, so I've got a full copper bus bar going down here and across, and put more of that insulation in between, but you see the copper bolts through to the copper plate that goes into the end there. it comes around and then winds up on this side over here. I made a bend in that copper bus bar, and I protected it with some plastic and some Captain tape on this corner here, so when it's not quite touching that, but even if it does, it's protected with the plastic plating. And then of course I've got a hole drilled and a bolt coming out of that right there, and I've lugged my 2.0 negative wire, and that goes into some flexible PVC conduit and then into my box. So we have both our positive and negative going into our new junction box there. In an earlier video, I already had this side of the Anderson disconnect, so I went ahead and just put this one on there. I probably don't really need it now. I don't think it hurts anything. I got my positive going up into here and into this big switch. This is another shutoff switch. Again, a little bit redundant. I thought it might be good to have a shutoff switch for the high voltage pack inside the car, as well as one in the back engine compartment that you've seen before. But I can always maybe get rid of that other one if I need to, just to shorten some cables. And then it goes, of course, out of there and into the positive. So there's my main two positive negatives going into there. Now, notice I have a fuse block here, and it's got 3 fuses in it. It's a little hard to see that first one, but it's P1, P2, and P3. Now, you would think that for the contactors, they're all going to close at the same time, so you would think that I would just wire them up, just a positive and negative, and they would all link to that. But what I decided to do was put fuses on each one, so each one has its own individual wire, each contactor, and they correlate to the 3 packs. The reason for this, and it's just kind of loosely wired right now, I have some wires going over to my DC command center. Right now, this little fuse block here with these 3 fuses in it is wired to my KSI output. What that KSI is essentially it's my ignition switch with a few other kills on it, like for the charging to kill it or for the impact switch to kill it. But other than that, it's pretty much my ignition switch. That will light up all these fuses, which will then close all the contactors at the same time. The reason I fused them separately is not because they needed it, but if you can imagine, like let's say I'm on the road 20 miles away from my house, and maybe like say I see smoke coming out of this battery module or something catastrophic happens. My BMS is saying this battery module has a big giant problem with it, and I need to just eliminate it, right? Well, what I can do is while I'm out on the road, I can just pull, let's say that's pack 3, I can just pull this fuse so it acts as more of a pack disconnect. So if I pull that fuse, then I'll be running on these 2 packs and not this one. So I could potentially isolate one of the packs, or one or more of the packs, and take it out of the circuit. Now, does that mean when I get home, I could just replace the module, this module here that had smoke coming out of it, and just put all the fuses back and I'm good to go? Well, no, because remember what I said in the previous video, and again, if you didn't watch my previous video and you're not sure how I wired this, that explains all that. So go to that previous video. But if I replace these 2 modules, now I have one pack that has a different voltage than my other 2 packs. So what I could do again with those fuses is put just the fuse for the pack 3 in here, right? Just pack 3 fuse in. Then I can charge, and I'm gonna have to disable the BMS. I'm just spitballing here. Until I get to the BMS, I don't know if this will work. But I could potentially charge this pack, only this pack, then pull out P3, put the other 2 back in, then charge these packs, try to even them out, and then once I get them even, then I can put all the fuses back together. So I don't know if that'll work. Like I said, the BMS might keep me from being able to do that, since the BMS is going to control the charger and the charge voltage and all that. But it's an option that I could potentially research. So by hooking those all separate up now, I have the ability to potentially do pack isolation and disconnects. Okay, enough talking about this thing. Let's see if it actually works. Okay, before I turn it on, let me just show you what I think we're going to expect here. Is I've got this loosely wired up to the KSI terminal here that's going to the controller. Again, that will give 12 volts for that when I turn the ignition switch on. And so when we hit the start position on the ignition switch, we should hear 1 click for all 3 of those contactors pulling in. Now down by the controller in my engine compartment here, if you watched previous video when I did this high voltage contactor box right here, all that's pretty much the same. I still have a main contactor in here with pre-charge wires from the controller. The way my controller works, it needs the KSI to have 12 volts constantly applied to it so that it stays on, but that does not pull in the contactor or allow it to actually run. There's a second wire in the controller wiring down here that's called the start wire. The start wire needs a 12 volt signal just temporarily, so a momentary contact switch, like the starter switch on the ignition, wherein it will initiate the pre-charge sequence using those orange wires across the contactor. Once the pre-charge is done, it will then excite the 12 volt coil on the contactor and pull it in, making it ready to drive. Okay, so here we go. Let's see what happens. Now I'm going to turn it to the start position. And you heard the click. So now we have our battery power in. I'm going to crank it to do that start button, that momentary contact here, and that will initiate the pre-charge, and we should hear that second click for the main contactor. There it is. The controller should be ready to operate. I'm going to go ahead and set you up on the back there so you can see it spin, and I'm going to push on the throttle pedal. All right, here we go. Let me give it a little throttle. Awesome. We have our official spin test completed. So that wraps up this video, and I'm going to call the battery pack essentially done for now. There's more stuff we want to do. I'm going to put a cover on it, and I'm going to do some more work inside that box. But upcoming videos, we've got the charger. I've got a new charger. My old charger turned out to not have the maximum voltage on it with the ability to charge this higher voltage pack. So I had to get a new one. And as well as I need to wire up not only the charging system to that MCU, but also all the BMS cabling for the battery modules for that MCU. So we've got that video coming up to get all the charging system ready to go and the BMS wiring going, as well as future videos on the state of charge gauge, on speed sensor, tachometer, lots more stuff to come there. But this is the first big milestone. We now have a working battery pack, so I'm super happy about that. So if you haven't subscribed yet, go ahead and subscribe so you're notified of new videos coming up, and I'll see you on the next one.